Hello and welcome to my pathetic attempt at regaining points on an exam that I failed terribly. As you can see, this is question 6 with part 1. Looking at the places where things are circled and crossed off, I realized after redoing it that my main mistake in this problem that cost me 5 points, I think, was, at least for part A, was choosing the wrong trigonometric function for the normal force and the force of friction and whatnot. So I mixed things up in my mind. I didn't draw it out. So what I found was that the normal force is not mg sine 40, but actually mg cosine 40, and it looked like I had that, and I crossed it out, and I wish I had not. And that being said, the force of friction is equal to mu k Fn, and Fn is mg cosine 40. So force of friction is mu k mg cosine 40. And on the opposite hand, the force downward is mg sine 40. So I just switched those things around, and redoing this problem, this part with the correct numbers, I've using the same formula, F net equals ma. I found that the acceleration is 8.42 meters per second squared. And then plugging that into my original set of steps here for final velocity, I found that the final velocity is 4.50 meters per second. As for the part B, here's part B. So I didn't get a whole lot of points in this, and I think my problem was that I wasn't sure what formula or set of formulas to use. And I tried using this spring force equals the negative spring constant times displacement, but since there are 2 missing variables and only 3 variables, it really didn't seem that to make that much sense. I think I misinterpreted what this big F vector stands for. It does not stand for the force the block exerts on the spring. It's I'm not even gonna finish my sentence. Not important. So I realized that the set of equations that I should probably use instead were the conservation of energy. So the initial kinetic energy plus the initial potential energy of the spring is equal to the final kinetic energy plus the final potential energy of the spring. That's what I decided on using. And since there is no spring potential energy initially, because the displacement is from its neutral is 0, there's only kinetic energy initial on one side. And since there is no kinetic energy final, because when the spring reaches its maximum compression, the block has stopped moving. That means there's only potential energy of the spring on the other side of the equation. So my equation looks like kinetic energy initial equals potential energy of the spring final, which is equal to 1/2 nv squared equals 1/2 k delta x squared. And then I just plugged in the numbers that I already know. 1/2 times 100 times delta x squared equals 1/2 times 0.3 times 4.5, which is the velocity I found in part A, squared. And I ended up in this problem with the maximum displacement is equal to 0.246 meters. Thank you for listening.